Good morning to all of you. Today our subject is mechanics of solid. Last class I have discussed what is shear force bending moment diagram, types of supports, types of load, how a beam bends. So today I will discuss what is shear force, what is bending moment, what are the sign conventions of shear force bending moment, then some diagrams, some problems relating to shear force bending moment. Now, what is shear force? Shear force. The shear force, the shear force at the cross section of a beam, cross section of a beam at a section is the sum of the is the sum of the vertical unbalanced vertical forces to the right or left of the section. Clear? The shear force at the cross section of beam at a section is the sum of the unbalanced vertical force to the left or right of the section. Bending moment. The bending moment BM the bending moment at the cross section of a beam may be defined as the sum of the moment of all forces to the left or right of the section or right of the section. Clear? So shear force is defined as the sum of the all vertical forces to right or left of the section. Similarly, the bending moment at the cross section of beam at section is defined as the moment of sum of the moment of all vertical forces to the left or right of the section. Now, what is sign convention? Sign convention. Now one shear force. Suppose this is section left upwards, right downwards, positive. Similarly, left downward, right upward, negative. At a section, all forces left upwards, right downwards at a section taken a positive. Similarly, all the forces left downward, right upward taken as negative. Clear? So one portion beam tend to slide with respect to other portion. So suppose we are taking all forces towards left, all upward forces towards left positive. Similarly, all downward forces towards right positive. Similarly, all left downward, right upward negative. Clear? Left upward, right downward. Are taken as positive. Taken as positive. Similarly, right upward, left downward are taken as negative. Clear? Similarly, sign convention for bending moment. Sign convention for bending moment. Clear? Suppose this is beam, the force applied this time, the beam bends like concavity at the top. This is positive. Concavity at the top is positive. Similarly, convexity at the top negative. This is negative. Concavity at the top positive, convexity at the top negative. That means this is called sagging. This is called hogging. Clear? So the moment is such that whenever a body is applied to forces, the moment is such that this forms a concavity at the top. The moment then the bending moment is positive. Similarly, the moment is such that it makes convexity at the top. This is called a negative. So, this is called Sagi bending moment. This is called Huggy bending moment. Clearly, left clockwise, right anti-clockwise. Positive, left anti-clockwise, right clockwise. Negative. Clear? Left clockwise, right anti-clockwise. Right anti-clockwise, positive. Similarly, left anti-clockwise, left anti-clockwise, and right clockwise. Negative. Clear? Now, some design points should be followed while drawing the shear force bending moment diagram. The following points should be considered. The following points should be considered while drawing the shear force and bending moment diagram. Clear? The following points should be considered while drawing the shear force and bending moment diagram. Number one, the positive value of shear force is plotted above the baseline, above the baseline, whereas the negative values are plotted the negative values of shear force are plotted below the baseline. Below the baseline. Clear? Suppose this is baseline. So above baseline, the positive values are taken. Below the baseline, the negative values are taken. Suppose AB is the baseline. AB. So above AB, plus signs are taken. Below AB, minus signs are taken. Number two. Number two, if there is a vertical load at a section, then the shear force is then the shear force is increases or decreases. Suddenly, that is by a vertical line. Clear? Number three, the shear force between two vertical loads is horizontal. Number three, the shear force between two vertical loads remains unchanged. Remains unchanged. That is horizontal. Remains constant. That is horizontal. Clear? Now one point, all values, all positive values taken above baseline, negative values taken below the baseline. Number two, if there is vertical load at a section, then the shear force increases or decreases suddenly. That is by a vertical straight line. Number three, the shear force between two vertical loads remains constant. That is horizontal. Clear? Number four, if there is a uniform distributed load, uniformly distributed load, then the shear force diagram will be inclined straight line, inclined straight line, and the bending moment diagram is a curve, Clear? If there is UDL, then the shear force diagram is inclined straight line and bending diagram is curve. Or 5. Number 5, the bending moment at the free end of a simply supported beam. Simply supported beam and at the two ends of a free end of a cantilever beam and at the two ends of a simply supported beam. Supported beam is 0. Clear? The bending moment at the two ends of a simply supported beam and at the free end of a cantilever beam is 0. Now we will draw shear force bending diagram for different types of beams. Number one, cantilever beam with point load at the free end. Suppose this is a cantilever beam AB, clear? One fix, other and P. Suppose this is load double. Draw the shear force bending diagram of this cantilever beam. Clear? Take a section XX at a distance small x from B. Clear? Consider a cantilever beam AB fixed at A and carries a load W at the free end B. Clear? Let length L, length is equal to L. Let L is length of the beam. Let L is equal to length of the beam L. Consider section XX consider a section xx at a distance small x from the P and B. P and B. Clear? Now we will draw shear force bending diagram, then shear force diagram, then bending moment diagram. First make calculation. Shear force calculation. Shear force calculation. Right? At B, the load W is acting. So just right B, shear force 0. Just left B, shear force W. Because W is acting at point B. Its right side when calculating 0, left side when we are calculating this is W. Shear force at B, just right 0. Clear? Shear force at B, just left W. This is 0. Similarly, between B and C, there is no load. So, when there is no load between 2 points, the shear force remains constant. That is represented by a straight line. So, shear force at B just left means shear force at C. Now, shear force at C is equal to W. From C to A, there is no load. So shear force at C is equal to shear force at A. Shear force at W. Clear? Scale. Scale. 1 cm is equal to W Newton. W Newton. Clear? Now, A, C, B. A, C, B. This is shear force diagram. This is shear force diagram. And this is bending moment diagram. Now, again make calculation for bending moment. BM calculation. Bending moment calculation. At B 0 because I already told you the bending moment at the free end of a cantilever beam at the two support of a simple supported beam is 0. Right? So bending moment at B is 0. Because At B there is no distance. So moment is a force on distance. Distance 0, its moment is 0. Now BM at C. Same C. W into X. W into X minus double X, because all downward movements right downward. Clear? Right downward, right side clockwise negative. So minus W into X. Similarly, at a bending out at a minus W into L, this is W into L, minus W into L. Right? Now, draw the shear force bending mode diagram. First, for CF, for SF. For SF, make scale 1 semi is equal to W Newton. At B, just write 0. Just write 0. Clear? At B, just left W, plus W. Suppose this is W. At C, W, this is W. At A, W, this is W. Clear? So start from B, W, W, W. Clear? So this is all are positive. So this is positive sign, plus. All positive values are taken above the baseline. Now for bending mode diagram. At B0, clear? At C, minus double X. Suppose this is minus double X. At A, minus double L. Suppose this is minus double L. This is first degree of X. So all are straight line. So 0, double X, double L. Clear? These all values are down negative. So the diagram is below the baseline. This is negative. This is negative. So the bending mode diagram is below the baseline. These are positive. So shear force diagram is above the baseline. Right? This is your theory. Next I will do some problem. This is question number 46. Very important question. This is a cantilever beam. The beam is acted upon by 3 loads. 1000 Newton each at a distance 0.5 meter, 1 meter, 1.5 meter from the left support. Draw the shear force bending mode diagram for the beam. The question is, a cantilever beam 1.5 meter long carrying point loads 1000 Newton each at a distance of 0.5 meter, 1 meter, 1.5 meter from the left support. Draw the shear force and bending moment diagram for the beam. Now, this is shear force diagram. This is for bending moment diagram. A, B, C, D. A, B, C, D. Clear? Now, first make calculation for shear force. Shear force calculation. Clear? At D just right. Shear force at D just right 0. Just left 1000 Newton. Shear force at D just left 1000 Newton. Right? From D to C there is no load. So the 1000 Newton remains constant from D left to C right. Shear force at C just right is equal to 1000 Newton. Right? At C 1000 Newton load is given. So that will calculate for left part of the C. So shear force at C just right 1000 plus 1000 2000 Newton. Clear? At B shear force at B just left, this is left, not right, just right. So between point D, C and B, no load. So C left means B right, 2000 Newton. Shear force at B just left. Shear force at B just left 2000 plus 1000 3000 Newton. Right? Next, at A, between B and A, there is no force. So shear force at A, B left means shear force at A at A. Shear force at A 3000 Newton. Clear? B left, A right, A, no load. So the shear force remains constant. Now draw the diagram. Scale. Scale 1 same is equal to 1000 Newton. 1000 Newton. Now at D just write 0. D just left 1000 Newton. So this is 1000 Newton. Clear? At D, C just right 1000 Newton. Just left 2000 Newton. C just left. B just right 2000 Newton. B just left 3000 Newton. A just left 3000 Newton. Clear? So draw the diagram. Start from D right, then 1000, then 2000, then 2000, then 3000, then 3000. Clear? This is all are positive. All are positive. Now, Bendimo diagram. First make Bendimo calculation. BM calculation. At D, bending moment at D is equal to 0 because 1000 into 0 is equal to 0. Bending moment at C, at D 0, at C 1000 into 0.5 minus 1000 into 0.5 minus 500 Newton meter. Clear? Bending moment at B, bending moment at B 1000 into 1 plus 1000 into 0.5 minus 1000 into 1 plus 1000 into 0.5. So this is minus 1000 plus 500 minus 1500 Newton meter. At B, at A, bending moment at A, this is 1000 into 1.5 plus 1000 into 1 plus 1000 into 0.5. Clear? Minus all are downwards, so this is negative. Right clockwise negative. So minus 1000 into 1.5 plus 1000 into 0.5 plus 1000 into 1 plus 0.5 is equal to minus 1500 plus 1000 plus 500 is equal to minus 3000 Newton meter. Clear? Now draw the bending moment diagram. Take scale. All are negative, so all are drawn below the baseline. This is bending moment shear force diagram. Now this is bending moment diagram. Scale. Take 1 cm is equal to 500 Newton meter. 500 Newton meter. Scale 1 cm is equal to 500 Newton meter. Right? Now at D 0 at C 500 minus 500 Newton meter. At B 1500 minus 1500 Newton meter. At A 3000 minus 3000 Newton meter. Clear? These are first degree of x. So all are inclined straight line. Starts from 0 minus 500, then 1500, then 3000. Clear? These are all are negative. All are negative. All are plotted below the baseline. All are negative. All are plotted below the baseline. So this is negative. This is negative. This is positive. The positive values are taken above baseline. The negative values are taken below the baseline. The shear force is vertical straight line, the horizontal straight line, this inclined straight line. Clear? Next question, 47. The question is, question 47. The question is, a cantilever beam 2 meter long carries 4 kilonewton, 5 kilonewton, 3 kilonewton at a distance of 1 meter, 1.5 meter and 5 meter from the left support. Draw the shear force and bending moment diagram for the beam. First draw the base diagram. This is cantilever beam AB 2 meter long. This is 1 meter, 1.5 meter, 2 meter. Clear? This is 1 meter, 0.5 meter, 0.5 meter. 4 kilonewton, 5 kilonewton, 3 kilonewton. A, B, C, D. Question is, this cantilever beam 2 meter long carries load 4 kilonewton, 5 kilonewton, 3 kilonewton at a distance 1 meter, 0.5 meter, 1.5 meter and 2 meter from the left support. Draw the shear force bending moment diagram for the beam. First make calculation for shear force. force calculation. Now, A, B, C, D, A, B, C, D. This is for shear force, this is for bending moment. Now, at D, shear force at a D just right. Shear force at D just right. 0. Shear force at a D just left 3 kilonewton. 3 kilonewton. Shear force at C just right 3 kilonewton. There is no load between D left and C right. 5 kilonewton given at point C. So shear force at a C just left 3 plus 5 8 kilonewton. Now C left, B right, same, no load. So C left is equal to B right. Shear force at a B just right 8 kilonewton. At B 4 kilonewton given. So that will be calculated for just left. Shear force at a B just left 8 plus 4 is equal to 12 kilonewton. At a shear force remains constant from B to A. Shear force at a 12 kilonewton. Right. Now draw the diagram, shear force diagram. Shear force diagram. Scale 1 cm is equal to 3 kilonewton meter. 3 kilonewton. 3 kilonewton. So at B, D just at 0. 0. At D just left 3 kilonewton means 1 cm. 3 kilonewton. At C just right 3 kilonewton. This is 3 kilonewton. At C just left 8 kilonewton. 8 kilonewton. At B just right 8 kilonewton. At B just left 12 kilonewton. At A 12 kilonewton. Clear? Now join all the points. Join all the points. 0, 3, 3, 8, 12, 12. Clear? All are positive, so all are above the baseline. All are positive. All are positive. Now, bending moment calculation. BM calculation. At D 0, because at D the moment of 3 kilonewton into distance 0, so bending moment is 0. So bending moment at D 0. At C 3000 into 3 kilonewton into 0.5 and 5 into 0, 0. At C 3 into 0.5, 1.5 kilonewton. At B its moment 0, so 3 into 1 plus 5 into 0.5, 3 into 1 plus 5 into 0.5, all are negative, so minus, downward mode minus, so this is minus 3 plus 2.5 minus 5.5 kilonewton meter. Now at a at a 3 into 2, 4 into 1, 5 into 1.5, right? 3 into 2 plus 5 into 1.5 plus 4 into 1, all are negative, all are negative. So this is minus 6 plus 7.5 plus 4, so minus 7.5 kilonewton meter, right? Draw the bending mode diagram. This is BM diagram. Scale 1 cm is equal to 1.5 kilonewton meter, right? Now at D 0, at C minus 1.5, C 1.5 minus, at B minus 5.5 minus 5.5 kilonewton meter, at A 7.5 Now join from D to C, C to B, B to A. This is inclined straight line. Inclined straight line. This is all are downwards, so negative. So the diagram is below the baseline, negative. Clear? So this is shear pole diagram, that is bending mode diagram. Our problem is 147. Next class I will do 48, 49, 50, like this. Clear? This is simple support. This is kettle beam carrying point load. I will do kettle beam carrying UDL, uniform distributed load. Thank you. Make, like, share, subscribe to all our channels. Thank you.